All right, let's jump right in. We are on the verge of completely rethinking the way we build our world. I'm not talking about small tweaks here and there. We're talking about a fundamental shift, moving beyond the old industrial playbook and looking for a smarter, more sustainable blueprint. And it turns out the best one has been in development for, about 3.8 billion years.
It all really boils down to this simple but incredibly powerful idea, captured perfectly by biologist Janine Benyus. What if, instead of just taking from nature, we started learning from it? What if we treated the natural world less like a warehouse of raw materials and more like a genius mentor who's already solved our biggest problems?
So why the big push for change? Well, to really get it, we first have to face the massive problem with our old way of doing things. The way we've been building our cities and making our products, it's just not working anymore.
I mean, the numbers are just staggering. The global construction industry alone is responsible for nearly 40% of all energy-related CO2 emissions. It generates a third of all our waste. This linear take, make, and throw away model is pushing our planet to the brink. And with our population growing every single day, it's a crisis that's only getting worse. We absolutely need a revolution.
Okay, so if our way is broken, where do we look for a better one? What if we could tap into the most successful R&D lab in the universe? Nature has been solving incredibly complex problems. We're talking energy efficiency, material science, structural engineering for billions of years through relentless trial and error.
And that brings us to this key concept, biomimicry. It's a great word, right? It comes from the Greek bios, meaning life, and mimesis, meaning to imitate, so life imitation. Instead of trying to invent everything from scratch, we look at the proven, time-tested strategies of the natural world to solve our own challenges. It's all about function, not just making something look like a leaf.
Let's make this real. Think about keeping a big building cool. Your first thought is probably air conditioning, right? Pumping tons of energy to fight the heat. But termites in Africa build these enormous mounds that stay at a nearly constant temperature inside, even when it's scorching hot or freezing cold outside. They do it with this brilliant system of vents that creates natural air conditioning. And this exact idea inspired a building in Zimbabwe that uses 90% less energy for cooling than a conventional building. 90%.
Or how about this one? How do you build something that's incredibly strong, but also incredibly light? Well, believe it or not, the answer is inside your own body. The top of your thigh bone, the femur, has this amazing internal lattice structure that gives it immense strength with very little material. And that exact principle, it inspired the design of the Eiffel Tower, allowing it to be so tall and strong while using a surprisingly small amount of iron.
Now, brilliant designs are one thing, but you can't build them out of thin air. The concrete and steel of the last century just aren't going to cut it. To really build like nature, we need a whole new toolbox, one that's guided by sustainability from the ground up.
And this right here, this is the paradigm shift. Green chemistry completely flips the old manufacturing model on its head. Instead of making something and then trying to figure out what to do with all the toxic waste, it designs the process from the very beginning to create no waste at all. It chooses reactions that sip energy instead of guzzling it, and it swaps out finite resources for renewable ones. It's a total game changer.
So what does this actually look like?
Well, you can forget those old, grimy images of factories with smokestacks. The factory of the future looks more like a living ecosystem. It's powered by renewables, everything is designed to be recycled, and the whole process is safer for both people and the planet. And the materials themselves are getting so much smarter. I mean, this stuff is almost science fiction. We're literally growing insulation and packaging material from Mycelium, which is the root structure of mushrooms. We've got bricks that actually pull CO2 out of the atmosphere, turning our buildings into carbon sinks. We're making plastics from cornstarch, and we're developing advanced carbon fiber to build the super lightweight infrastructure we need for a hydrogen economy.
Okay, so we've got nature's brilliant designs and a toolbox of incredible new materials. How do we bring it all together with precision? That's where the digital world comes in, acting as the master architect.
It all starts on the computer with CAD, computer-aided design. But this is way beyond just digital drawing now. We can use algorithms for something called topology optimization, which is basically a fancy way of asking the computer, hey, what is the absolute minimum amount of material I need here for this thing not to break? The computer then carves away everything that's not essential, leaving behind these incredibly strong and lightweight forms that, guess what, often look a lot like things we see in nature, like bones.
So once you have that super efficient design, you have to make sure it's actually going to work. In the old days, this meant building a ton of expensive physical prototypes and literally smashing them to see when they'd break. Not anymore. Now, with finite element analysis, or FEA, we can break it 1,000 times on a screen. We can simulate decades of heat, stress, and vibration in just a few hours, making sure our new sustainable materials are up for the job before we ever make a single physical part.
And finally, we have to actually make the thing. That's where CAM, or computer-aided manufacturing, comes in. Think of it as a hyper-intelligent GPS for the machinery. It calculates the most efficient tool path possible, so instead of carving a part out of a big block and creating tons of waste, it builds it precisely, layer by layer, or with the most efficient cuts. This radically slashes scrap material and energy consumption. It's the final piece of the puzzle.
But here's where it gets really mind-blowing. We're not just building smarter objects anymore. We're giving them a nervous system. By embedding tiny Internet of Things, or IoT sensors, our infrastructure can become responsive. It becomes alive. Our bridge can literally tell us it's feeling stressed before a crack ever forms. A building can adjust its own energy use in real time based on who's inside and what they're doing.
Okay, let's put it all together now. What happens when you combine nature's genius blueprint with these new green materials and this incredible digital intelligence? You don't just get a better version of the old world, you start building a fundamentally different and a much, much better future.
You start to get smart infrastructure, like these piezoelectric pavers. Now, these aren't just regular tiles. They have this amazing property where they convert the pressure from something as simple as a footstep into a little bit of electrical energy. Just imagine a busy train station or a sidewalk powering its own lights, just from people walking around.
And when you scale that kind of thinking up, you start to get entire buildings that are net zero, meaning over a year, they produce as much energy as they consume. And from there, you get whole smart cities that can optimize everything. Traffic, the power grid, water usage, all in real time, making them way more efficient and resilient.
And this revolution isn't just about buildings. We can transform entire industries like automotive manufacturing so they run on clean energy and build cars from lightweight, green materials. We can create systems that finally work in harmony with the environment, not against it.
So in the end, it really all comes down to this. We are at this incredible moment. Nature has given us the blueprint, honed over billions of years, and technology has finally given us the tools to understand and execute that vision with unbelievable precision. The only question left is, what will we choose to build?